Hey everybody, so let's talk about a mole. Woo! All right. Um we had cereal day and I wanted to, before we talk about a mole, let's talk about a bowl. So a bowl is defined by me as being 175 pieces of cereal. That's what a bowl of cereal. And as if you look at this bowl of cereal right here, you would see that that's about a decent serving of Cheerios, right? So that's 175 pieces of Cheerios. Now, if we made a bowl of frosted mini wheats with 175 pieces, you can see this wonderful tower of architectural genius that I've done with the mini wheats. Has one thing in common with the Cheerios in that there are 175 pieces of cereal. But as you might imagine, the mass is not going to be the same and it doesn't look the same. Also, if we add a bowl of Rice Krispies, right there, 175 pieces of Rice Krispies, that would also be um, different than the Cheerios and the frosted mini wheats. So all of these I defined as a bowl, and what they all have in common is they all have 175 pieces. But as you can see, they take up different space and they would have different masses. And that's similar to what the chemists have come up with the mole, the concept of the mole. So just like a bowl is a certain number of cereal pieces, a mole is a certain number of atoms that allow all these numbers here. I'm going to try to do this, kids. There we go. So these numbers here to be grams. So if you have a mole of nitrogen, it would be 14.007 grams. And if you had a mole of carbon, it would be 12.011 grams. So how many atoms do we need for all these numbers to be grams? That's what the mole was invented for. And it turns out that, sorry about that, kids. There was two bowls. If we had two bowls, you could figure out, because you know that one bowl has 175 pieces in it, right? Come on. All right, it's going to be 175 pieces. So this is our equivalence that we just did. So you can put the bowl on the bottom and the 175 pieces on the top. Bowls will cancel and the 175 pieces will stand. So that will be the units of our answer. And then 2 times 175 gives you the 350. So that works out pretty well, I think. And then if we wanted to say, well, if a bowl of Cheerios is 30 grams, how many grams would be they in 4 bowls of Cheerios? So we have we have the 4 bowls given, right? So the 4 bowls is given, and we're trying to use this tool to go from bowls to Cheerios grams. And so we'll put the bowls on the bottom and the grams on the top, and that'll allow us to cancel bowls and move along with Cheerios. So 4 times 30 would be 120 grams of Cheerios in 4 bowls. All right. So that all has to do with the mole. The mole was developed by this guy named Amadeo Avogadro. And what he did was determine that for everything on the periodic table to be grams, it would require us to have 6.02 times 10 to the 23rd atoms. So in this case, he was talking about atoms to make everything on the periodic table be a gram. Now, a lot of these numbers, as you know, came from the average atomic mass of a group of atoms of different isotopes with that of that element. So zinc, for example, has different isotopes, and when you take into account the percentage of their existence and what each one weighs, and those are typically whole numbers, they average out to 65.38. And what Avogadro said was if you have 6.02 times 10 to the 23rd atoms of zinc, it would weigh 65.38 grams. And if you had 6.02 times 10 to the 23rd atoms of, say, aluminum, it would weigh 26.982 grams. So what Avogadro did was find a number that allowed everything on the periodic table to go from atomic mass units to grams. And that was a huge thing for us. So I need to stop hitting that button. That number, 6.02 times 10 to the 23rd, is known as Avogadro's number. And everything on the periodic table now has the units of grams instead of atomic mass units. So 1 mole of carbon would be how many atoms? It would be 6.02 times 10 to the 23rd. So this is just like with the bowl of cereal. How many atoms do you need in 1 mole? Mole is defined as having 6.02 times 10 to the 23rd things. So if I said how many bikes are in a mole of bikes, it would be 6.02 times 10 to the 23rd. Or how many pillows would there be in a mole of pillows? It would be 6.02 times 10 to the 23rd. But the mass of a mole of carbon, we now have to go to the periodic table, look for carbon. Here it is. And we're going to use that mass number, that 12.011, that out. So that is 12.011 grams, that being a 0. That's how many grams are in a mole of carbon. Now, if we had a mole of sulfur, it would have the same number of atoms as the carbon, 6.02 times 10 to the 23rd. But the mass of a mole of sulfur would be a little different. Sulfur is here, number 16. So that would actually be 32.06. So that is 32.06 grams of sulfur in every mole. Now, why is this helpful? It's helpful because oftentimes in the lab, we want to know grams and basically how many atoms we have, and we want to make sure atoms to atoms that there's enough there to react with everything else that we're reacting to the other atoms. So here I have a picture of a mole of silver because it's a mole. That is a mole. And we have 0.275 moles of silver. So if we have 0.275 moles of silver, and the question is how many grams? So in order for us to figure that out, we would need a relationship between moles of silver and, I don't know why that happened, grams of silver. And the relationship moles of silver to grams of silver comes from the periodic table. Silver is here, number 47. So 107.87 would tell us 107.87 grams is how many grams there are in 1 mole of silver. Let's erase that, shall we? I guess I can. There, let's see if I can. Oh, I erased the whole A. Magic. Okay, AG. So we're going to start here with our little scaffolding or dominoes or whatever it is you want to call these. And since we're trying to cancel moles of silver, we're going to want moles of silver in the denominator. And since our thing is looking for grams, it's asking for grams, we're going to want the grams of silver on the top. And that relationship, based on our relationship here, is 107.87. So we got that from the periodic table. That's how many grams. I don't need you yet. That's how many grams there are in 1 mole of silver. So now the moles of silver cancel. We have grams of silver up there, and we can now do the math. And I don't have a calculator, but let's see if my phone can quickly act like a calculator. So 0.275 times 107.87. There we go, 29.66. Doesn't sound great. Please stop doing that. 29.664. So this has, you may recall, 3 significant digits, and this number here, 1, 2, 3, 4, 5 significant digits. So our answer needs to have 3 significant digits, so that would be 29.7 grams is what that would equal with 3 significant digits. All right, let's talk about this one now. If we have atoms, in this case, the number we have here is 3.89 times 10 to the 26 atoms. Let me put that in the orange is what I wanted. So we're given 3.89 times 10 to the 26 atoms of helium. And the question is, how many moles is that? So we want to get rid of atoms and go to moles. And we know the relationship is there are 6.02 times 10 to the 23rd atoms in 1 mole of any substance. Doesn't matter if it's helium or oxygen or whatever, but we're going to use 1 mole of helium here because that's what we're dealing with. All right, so we need to get rid of atoms and we want to get to moles. So we're going to put this atoms thing, in the denominator, 6.02 times 10 to the 23rd atoms. And that will cancel out the atoms of helium. And then the 1 mole of helium will go in the numerator. That goes in the numerator. We've canceled out atoms. We have moles. The question was asking for moles, so we're in great shape. Now we need to multiply the tops and divide by the bottoms. Now, this is difficult with these scientific notations when you're using a calculator. So you can put the top one in any form you want. But if we want to put this number in as, if we put that in our calculator as 6.02 times 10, and then we hit the little caret and we hit 23, that's not going to work if we divide the 3.89 times 10 to the 26 by that, because all it'll divide by is a 6.02, not the times 10 to the 23rd. So if you like to use this method for your calculator, you're going to want to put all of this in parentheses so that the calculator knows to use the whole number and not just the 6.02. You want the 6.02 times 10 to the 23rd. If, however, you don't like to use parentheses, you can use another method, which is the 6.02, and then you're going to hit the E function and put 23. So remember that E is equal to times 10, and then the next thing you put in will be the exponent of the 10. So it would be 23rd. Times 10 to the 23rd is what 6.02 E23 means. So if you use this red one, you don't need to use parentheses. If you use this purple one, you are going to need to use parentheses. So I'm going to do that real quick on my cheapy calculator here, unfortunately. So 3.89 to the 26th divided by 6.02 to the 23rd. And what I get is 646, the answer to this. Ooh, don't need you yet. The answer to that is 646.179, 646.179. And again, if we look at significant figures, this 3.89 has 3 significant figures. This is a definition, so we try not to let that be what determines our significant figures. So we want this answer to have 3 significant figures, so that would be 646. That's not the prettiest, but moles of helium. All right. So let's just do real quick another one of these. If we have 547 moles of tin in a Tin Man, and we're looking for how many grams would it take to do that, we're going to start with the 547 moles. That's what's given and all by itself of tin, which is SN. And we're going to go to our periodic table. Hold on, kids, while we do that. Here is tin. What you see there is that a mole of tin has 118.71 grams. So 1 mole of tin has 17, whoops, I don't remember anymore. And what was it? 118.71. There you go. 118.71 grams of tin. And we also know, you recall, that 1 mole of tin has 6.02 times 10 to the 23rd atoms. So which of these two things is going to be helpful in this problem? Well, we have moles of tin, and we're looking for, if you look here, we're looking for grams. So since we're looking for grams, this first statement is going to be helpful. So we're going to want to get rid of our moles by putting them in the denominator, 1 mole of tin. And we're going to want to get to grams by putting that in the numerator, 118.71 grams of tin. And we're going to multiply the tops. These will now cancel. And the only thing left standing is the grams of tin as far as units are concerned. And then if I do 547 times 118.71, we get, whole bunch. 64,934. 64,934 grams. Which needs to be 3 significant digits. So you can do 6.49 times 10 to the 1, 2, 3, 4. That's a nice way to do it. Or you can just do 64900. 64900 grams. Either one of those works. All right. So I hope that's helpful. Those of you who missed class, maybe that'll help get you started. We're going to do more of this all week. So do not fear if you don't understand it this second. We're going to have a lot more. Thanks, kids.